Hello, I'm David Liu, first author of our paper Digital Twin DT CycleGAN, enabling zero-shot sim-to-real transfer over visual grasping models. First, I'd like to briefly introduce the core concepts of our paper. As shown in this figure, our digital twin CycleGAN framework consists of three major components, including the physical/DT robots on the left of this figure, grasping agent action network on the right of this figure, and the DT CycleGAN model in the middle of this figure. In general, our work contributed a conceptually new DT CycleGAN framework by integrating the advantages of both digital twin methodology and the CycleGAN model so that the reality gap can be effectively bridged. In our framework, the reality gap in zero-shot sim-to-real transfer of visual grasping models is defined as grasping action consistency losses and intrinsically penalized during the DT CycleGAN training process in realistic simulation environments. Specifically, first, cycle consistency losses between real visual images and simulation images are defined and minimized to reduce the reality gaps in visual appearances during visual grasping tasks. Second, the grasping agent's action consistency losses are defined and penalized to minimize the inconsistency of the grasping agent's actions between the virtual states generated by the CycleGAN generator and the real visual states. By jointly penalizing both the cycle consistency losses and the grasping agent's action consistency losses in DT CycleGAN, the reality gaps in both visual appearance and grasping action states in simulated and real environments are minimized, thus significantly contributing to the effective and robust zero-shot sim-to-real transfer of the trained visual grasping models. Here we will show a few video examples of our experiments. Here, these are three examples of visual grasping in complex backgrounds. Here we show three examples of visual grasping in plain backgrounds. And here we show one example of visual grasping in a virtual environment. In addition, here's three additional examples of visual grasping in complex backgrounds. And here we have a few examples of visual grasping of unseen objects in complex backgrounds. And here's one example of when the robotic visual grasping fails.